Welcome students. So till earlier class we have seen how sound is produced and what are the different mediums that are used for traveling of sound and why medium of sound is very necessary, because without any medium sound cannot be traveled, isn't it? It cannot be propagated. Today we are going to see what is frequency of sound wave. What does meaning of frequency? What is that term that we are going to try to understand today? So you see how the vibrations of a tuning fork is taking place, or any vibrating object is making a sound, that we have understood yesterday of compressions and rarefactions. Actually, there are compressions and there are rarefactions, and in compressions there it is increased pressure. In rarefactions, the pressure is reduced from the mean position, and with the help of those in the air, sound is being produced. From the mean position, the object moves up and down, vibrating situation. In that case, when it goes up, compression, increased pressure. When it goes down, rarefaction, reduced pressure. That way we have to understand. So one compression and one rarefaction together forms a oscillation. One oscillation constituting of one compression and one rarefaction. So here you can see one rarefaction, one compression. This part we can call it as a one oscillation. Actually, we all have heard about the oscillation of a pendulum. Pendulum oscillates when it is moving to and fro from its original position. This is the mean position of the pendulum. It goes towards the right, it goes towards the left. So you can see oscillation. One oscillation means one last position to the another last position and again going back. That creates a one complete oscillation. So this is an oscillation of a pendulum. But in case of sound waves, where we have compressions and rarefactions, one compression and one rarefaction together forms one oscillation. Okay? Just like that of a pendulum. But in case of pendulum, the working is different. In case of sound waves, working is different. Here we have a compression and one rarefaction. Here the pendulum is moving from the last A, B and C. If we consider these 3 points, from the mean A position it goes to the B, from B to C, C to B again. That is one oscillation for a pendulum. Here it is different, but then also we term it as one oscillation only. Okay. So vibrations can be shown in this way, wave vibrations of sound waves. The actual vibration in the air, density and pressure can be considered in a different way. You see, during compression, the waves are very close to each other with the particles, and in rarefactions, they go away from each other. If you want to understand the compression, you see here the waves are very close to each other in the air. Okay, so this is your compression. And in case of rarefaction, the waves are little scattered away from each other. The frequency is low, here the more combined, very close to each other. So that way we have to understand compressions and rarefactions. Now medium, already we all have seen that we need some or the other medium to travel the sound. There are three mediums on our earth. We have air, that is mixture of gases. We have solids like any table, any clock, or any other object that is compact. And one another state we know is that of liquids. In liquids, the molecules are little scattered compared to solid, and they are compact enough, not as much as scattered like the gaseous state. So three different media are there to travel propagation of sound. For propagation of sound, we need some or the other medium, and the mediums that we have are three gases. It could be liquid, it could be solids. Okay, these are the three different medium available on Earth. The question arises, in which medium will the sound travel faster? What is your idea about that? What do you think? In which medium is the sound going to be moving faster, and in which medium the sound is going to move slower? You see, as we already know that in solids, the molecules are arranged in a compact way, very close to each other. Okay? In case of liquids, if you see, the molecules are little away from each other. And finally, if you come to the gaseous state, in gaseous state, what is the arrangement of molecules? They are very much scattered, very far away from each other. So, from these three figures, we can easily understand which medium sound is going to be traveling faster. You can see here, as these molecules are very close to each other, propagation is faster. Here, propagation is faster because molecules are very compactly arranged. In case of liquids, it is medium where molecules are little close to each other. So it may take some time, but propagation will take place. Not as fast as solids. And in case of gases, propagation will be slow. Why? Because there is a lot of gap between the two molecules of any substance. So you can understand air is a mixture of gases, that is the medium maximum we are utilizing for propagation of sound, but it is the slowest way of propagation of sound waves compared to solids and liquids. Okay, so mediums we have understood. Then about the frequency, we try to understand that in case of compression, where the pressure is more or increased, you can see the density of air and waves passing through them. And in case of rarefaction, where the density is less, waves will be little slow. Okay. Now, this way cycle is going on, and air pressure is also creating a effect on propagation of sound. Okay. Now, one compression and one rarefaction together forms one cycle of the wave. Just like pendulum going from B to C and C to B, one oscillation. Similarly, for wave, one compression and one ray of action together forms one oscillation. The number of cycles formed in the air is 1 second, will be decided by the number of times of the prongs of the tuning fork are vibrating. How much time? In 1 second, how many oscillations? So the time period is also very important in measuring these oscillations. 1 second, if we consider in 1 second, how many oscillations by the pendulum? In 1 second, how many compressions and rough actions of the sound waves? Okay, and vibrating back, the number of vibrations of the tuning fork in 1 second we have to measure. Now, number of such cycles that are produced in the air per second is called as the frequency. So, what is frequency? What is frequency? From this you can coin a formula. Frequency means number of oscillations in 1 second. How many oscillations in 1 second will be the frequency of that sound wave? And the tuning fork, if you consider in per second how much it is going to vibrate from its mean position up and down. These vibrations will set about 512 cycles of compressions and rarefactions in the air per second. Thus, the sound generated by the tuning fork will have a frequency of 512 hertz. Now, the unit, SI unit of frequency is hertz, Hz. Okay. So, you can see that frequency is measured in a unit called hertz, which was actually invented by the scientist H.E.R.T.Z. Hertz. That's why the name of the scientist is used as the unit for frequency, that is hertz. So we measure frequency in hertz. Okay, and the sound generated by the tuning fork will have a frequency in that way as much we have measured in 1 second. Here you can perform this type of experiments in home also. You can have a jal tarang, you can have glass pots filled with different amount of waters in them and tickle them with small sticks and listen to the sound. Different waves creating different amount of sound will be seen. So an app for measurement of sound frequency may be available on the cell phone also. Nowadays we have cell phone, everyone, isn't it? And that's way we can separate depending upon the frequency in hertz. If the sound that is coming to your ears is music or is it noise pollution? Okay. Sound waves of different frequencies produce different waves, and because of that different waves, different notes are created, musical notes also. And in the field of music, various musical instruments are used for creation of sound notes. This includes instruments like sitar, violin, guitar. You all must have seen them, which are string instruments, Then there are certain other instruments like tabla and dholak, which are called as percussion instrument, because there is a skin on which we have to tap for creating certain sound. And certain wind instruments are also there, where we have to blow in with the air, like the flute or shehnai, isn't it? And in string-based instrument, the frequency of vibration of the string is changed by the change in the tension, the how tightly the string is being tied on the finger or plucked by the finger. This results in generation of different notes. Musical notes are created, and in musical instruments like flute, we have to blow with the air and block the holes with our finger, therefore changing the result of the production of different notes. And different notes can be generated by changing the way of air blowing also. So all the type of instruments, sitar, flute, shehnai, violin, tabla, then all these things, wind instrument, percussion instrument, and string instruments are used for creating musical notes. The further part about how sound is created from our throat and how we listen with our ears, that we shall study in the next class. So thank you all of you. Bye-bye.